Once again, kind of go through some very quick review. Because it's very easy to start forgetting things, and then next thing you know, the final's gonna be here and all the questions look exactly the same, okay, so let's kind of remember that we started off in chapter 7, central limit theorem, gave us a lot of like reasons why we should believe what's happening, okay? Take enough samples of something, it's gonna approximate a normal curve. And they do suggest you always take enough samples that with at least, if you're dealing with mean, you want the samples greater than 30. Okay, proportions, it's gonna be greater than 10, or it's gonna be an n times p thing. Okay, we'll get into that again. Okay. So when thinking of 8.1, like I said, this is just really quick review. When thinking of 8.1, it said estimating populations means sigma known. That means they are going to give you your standard deviation, okay? That standard deviation is going to be a population. They're literally going to say that, okay? The population standard deviation is this, okay? Remember, that's also where you started learning about confidence intervals. Those are in your book, okay? I will be giving you those, but you need to know how to use those or know how to do it on your calculator, okay? Remember, for whenever you're doing that, you can use that button on your calculator called a Z interval. Okay, pop everything into that little thing, it gives it out to you. Or you can use the chart that's in your book. It's up to you. Okay. The biggest thing to remember though is when you are taking your final later on, you need to be able to look at it and go, okay, how do I know what they're asking? Well, they're going to tell you we want a confidence interval. Going to give it to you. Then they're going to say, here's your mean. Okay, cool. Some mean of some data, of some sample they've taken. Okay, remember that's going to be our point estimate. Okay, that's going to be our plus or minus, and we're going to be going backwards. We're going to find an error, and we're going to go plus and minus from that mean. Okay, and for A1, they're going to give you the standard deviation. They're going to tell you the population standard deviation is XYZ. Well, then we continued on to A2, okay? A2, we learned about the student's t distribution, okay? Learned about how you look it up on your chart, okay? You gotta look for degrees of freedom, and then you take the area of a tail. The only time you're gonna have a negative is whenever it's the area to the left, okay? You tell you, and how do you find what tail you're going to use? They're going to give you a confidence interval. You subtract that from 1 divided by 2, and then you have to decide, is it a 1 tail or 2 tail? So far, so good on that? Okay. And then we got to 8.3, and I'm going to kind of go back over 8.3 very quickly today. But remember, that's estimating population means when sigma is unknown, okay? Now, and that's where we're going to kind of start off. Like I said, I'm going to go through this super quick since we've already kind of done it. But for sigma unknown. And then we're going to do 8.4. It's going to be really important for you to bring your book when we start 8.5. 8.5 does not have calculator work. 8.5, you have to use the chart. Okay? And it's going to be a chart you're going to have to use on your final. Okay? You're going to have to know how to look up stuff because it's going to be another type of distribution we're going to start using. Okay, but like I said, whenever this is a sigma unknown, okay. So when doing sigma unknown, remember that's why they gave us that student's t distribution. So got to make sure all these things apply. Good news is on your final, everything's always going to work for you. I'm going to tell you that right now to kind of give you a little bit of like relaxation. It will always work. Okay. But remember, you need to look for something. Is there an appropriate amount of samples? That means greater than 30. Or if there's less than 30, I guarantee you they're going to be saying that the distribution is approximated normally. Okay? You got to have one or the other. Okay? And that goes back to why we learned central limit theorem. Okay? Central limit theorem says that. And then, of course, here's how you find error. Okay, E is equal to that t-score value, that student's t distribution. Notice they have changed the standard deviation, okay, it is now an S. Okay, which means that's sample standard deviation. And then one thing that if you don't read it carefully, you gotta look at the degrees of freedom. Remember, degrees of freedom now are n-1. Okay, so when you start looking this up on your on your table, and it says, "Hey, what's your degrees of freedom?" They're not going to tell you this is the degrees of freedom. They're going to give you a sample size. Okay, so it's going to be your sample size minus 1. That will be your degrees of freedom. And then we just have a few little examples here. This one right here, this one we just found the error. We didn't have anything else yet, but we found the error. Okay, and remember, you can use this on your chart in your book. They give us a degrees of freedom. Okay, because they give me an n value, which was 10. So I know my degrees of freedom is 9. It's always just 1 minus that. Okay, they also give me a C value of 95%, but I know that I've got to find the area. Okay, so I just go 1 minus 0.95 is equal to 0.05. Divide that number by 2, and that's going to be 0.025. And so that's the number I need to look at, that 0.025 and degrees of freedom. I find my number there. Okay, and so you have something you can plug in now. And notice they also give us an S up here of 15.5. And then we can calculate E, being your T, alpha over 2, multiplied by your sample standard deviation, divided by the square root of your sample size. And there's your formula. Remember, this guy right here would have ended up equaling that 2.262. So that would have been 2.262 times 15.5 divided by the, what is that, 10. One thing a note here is, look, remember what I said. The sample size isn't greater than 30. Okay? But notice what they say right after that. The distribution is approximately normal. Because one of those conditions has to be met. If you have over 30, who cares about the distribution? Okay? About the population. We don't care. Because the central limit there tells me if I take enough samples, that's going to approximate normal just by the sheer amount of samples I've taken. Anything less than that, then I need to make sure it is kind of normally distributed. Okay? Which you can tell by graphing. And then once you do all this, of course, you get this. Pins are working a little weird today. 11.08 and some change. And that would be if you had a mean. That's the number you would plus or minus from the mean, right? And that gave you that confidence interval that you learned how to do in A1. And that's literally what you're doing in every single homework in chapter 8. Sort of a hint. If it says build a confidence interval in your final, you kind of go, okay, I'm in chapter 8 right now. What did we do in chapter 8? Okay, well, we're building confidence intervals. Okay, well, am I using a t-score or that z interval, or sorry, the critical z value, or that student's t distribution? Okay, now let me parse out some information. They gave me a standard deviation. And that's really what you got to look at. They're giving me a standard deviation. Is that standard of population? Oh, that's where they got that standard deviation. I'm using that critical z value. Oh, they gave me a sample standard deviation. Oh, I'm using that student's t distribution. Okay, that's how you kind of know which one you need to use. Okay, and then pretty much the formula is almost exactly the same. It just depends on what type of standard deviation you're using. Okay, which remember, I will give you all the formulas. Okay, that's going to be the good news. I do give you the formulas. And the reason I wanted to review this one is this reason right here. Notice that's what I said, the plus or minus the mean. Let me show you an example that we did in class. Let me work this one out. Once again, let's hope the pin's going to work a little better. It's being a little wonky today. I can fix it, but I don't want to waste time right now. So notice a wildlife conservation study in grizzly bears. I think we did this one. We do all alone. Check here. Actually, let's do that one up there. A random sample, because I didn't do this one in class. A random sample of 11 fields of corn has a mean yield of 21.3 bushels per acre and a standard deviation of 2.09 bushels per acre. Determine the 95% confidence interval for the true mean yield. Notice it's telling me I'm looking for a confidence interval. So that's going to be ding, ding, ding. I'm going back to chapter 8 in my head. Okay, so I'm putting myself in the thought of taking the final. Okay, I know I'm in chapter 8. That's when we did confidence interval. Okay, well, notice they start off the right off the bat. A random sample of 11 fields of corn has a mean yield of 21.3. Everything's talking about samples per acre and a standard deviation of 2.09 bushels per acre. Did they specifically say the words population standard deviation? No. Everything is in reference to a sample, so I know, guess what? I'm using that student's t-distribution. That's going to be the guy I'm looking for, okay? So of course you would come in here, you need to go and put out some values here. N is equal to, ain't working there. I need a new pen tip. Maybe that time. Let's fix this here a little bit. N is equal to 11. Okay, notice what's going to be my degrees of freedom. It's always what?
1 minus.
N minus 1. So that's going to be your degrees of freedom. So your degrees of freedom, let's see if it's going to write it. Oh, that's maybe. You one of those days. The degrees of freedom, I'm just going to just talk it out. Degrees of freedom is going to be 10. Okay. They give me an X bar. Okay, the X bar is going to be 21.3. All of this I'm reading, I'm getting straight from the question, right? They also give me a sample standard deviation of 209. Okay, 2.09, I apologize. A critical value of 95%, which means, okay, not that you're 95% confident, don't think of it that way. It's that if you had enough samples, like say I took 100 samples, okay, like I did this trial 100 times, I am relatively confident that the actual mean would be in 95 of those, okay, and then 5 of those, it wouldn't be. Okay, that's what you're really kind of saying when doing something like this. And here's the good news. All this time, now first off, you can, if you want to look for a t-score, for that student's t-value, remember, you don't have to use this. You don't have to use your chart. Okay, if you don't want to, you can use that inverse T button. If you have the TI-84, 83 can't. Okay, 83 has to use the chart. Okay, which is fine. It works out just it works out just the same. See right now, let me see if it's going to write it. Once again, like I said, we're having some technical difficulties this morning. On this one, right here, let you see my notes right now. I want to show y'all something. Let me share content. Here. Okay. Notice what I got. Okay, you can see it on the screen now. I end up getting this 19.9, 22.7 right here at the bottom. Just pull this out here so you can see it. It's good to have an iPad. Yeah, you want the good news? I think you have this button. Check real fast for me. Go into your calculator. And you're going to hit your stat key. Scroll over to tests. And I do believe the 83s have this too, so let me know, okay? Double check with me, okay? You're going to scroll all the way down to number 8. It should say T interval. And then click that. And enter. Make sure that on input, you highlight stats. Notice it should give you 3 different things, an X bar. Now, I'll be honest, on TI-83s, this may be separated by commas, so just kind of listen to me, you may need to write this down. First off is going to be your mean, your X bar. Click on this one right here. They give us a what? A 21.3, right? So you can put that in, 21.3. Then scroll down, they give us a standard deviation, right? But it's a sample standard deviation, okay? So when we put that in, on this one right here, we put in our 209. Our N value is 11, and then what is our confidence level? 95%, right? Got a really weird number, realize once again I put 200 on the standard deviation, not 2.09, because it was. And then you'll see that you automatically get. You never get the almost roughly the same thing what I got if you rounded it. If you get look at the very top number on there. You should have got 19.896 and 22.704. Did you get that for your interval? Yeah. So it'll do the T-score for you. Okay? Which, if you want to do that, great. Just make sure that on your, first off, I know you got it wrong on your test because you got the wrong answer. But on your scratch paper, just put on, hey, question number, let's just say 7. This is what I did. I used the T interval. And then just make sure you put down, tell me, this is what I put for my mean. This is what I put for my standard deviation. This is what I put for the confidence interval. And then round accordingly. Okay? That's what I consider showing your work. That can help you out a little bit. If you don't want to use that, but you still kind of want to have the advantage of having a calculator, you can still use this calc inverse T. That will find you your T-score. Okay. Except for the 83s, you don't have to use your chart, or you can go straight to your T interval. Okay. So let me write this down for you. Remember, you're going to go to stat, test, and then T interval. If you remember correctly, remember in 8.1, I told you could go to what? What's right before that? Your Z interval. So if you were doing 8.1, you could do your Z interval instead. Okay? Instead of having to plug everything in, use your Z interval. Okay? And then just make sure on this one, you have to highlight stats. Okay? So when you do it, highlight that part right there. You can't be putting under data. You need to scroll over and highlight stats. Does anybody want to see me do it on my calculator real quick just so you can kind of see it? You're not my. I'll use the same numbers. Okay, watch carefully. Remember, I just stat key. Scroll over to tests. Everybody see that okay? Oh, sorry, it's not showing. Scroll over to tests. I'll start it. Stat, scroll to test. Go down to number 8 or just hit 8. Okay. If I was in 8.1, notice what I do. I would go to number 7. That's your Z interval. It's exactly the same thing, except it's using that critical value of Z, okay, and it's going to be using a population standard deviation. Whereas this one, if you notice on whenever I click on the T interval, I hit enter, make sure my stats is highlighted. Notice it gives me a mean, but notice it's giving me the sample standard deviation because that's what it's wanting, okay? And then once again, it gives me an N value, and then that confidence interval, it calculates. You notice exactly what I just got for an answer by doing the other one was by hand. Okay, on this one right here, you just have to make sure to get. There. Why is it giving you a weird answer? Oh, I put a different number. Yeah, sorry. Come over here, go back down. Put in what do we put in? 21.3. Standard of 2.09, and then an N value of 11, and we're confident at that. And there you go, 19.86, which on my answer, you'll notice I got 19.9. So just round accordingly. And they tell you, it says round to 1 decimal place. They'll tell you what to round to. Okay. Either way, I don't care. Do what you want. Okay, you can, if you want to do it by hand, have at it. There are some people in here that love doing it by hand. It doesn't take that much, it takes a little bit longer, but you've got time either way you want to do it on your final. If you decide to do everything by hand, you got time, okay? Unless of course you decide to start taking your standard deviations like that. You good on that? All right. Let's jump into the next lesson then. Eight point four. I'll go with my deal and yours. 8.4, we'll see if the pen is working now for this. I doubt it, but I'll find out. See. Nope, okay. That is okay. 8.4 is estimating population means, okay? Okay, estimating population proportion. Only when you're doing means are you going to be using that, okay. The only time you're going to be using means, the way I just did them just now, okay, or using that student's T distribution, when doing the critical value, you'll do it again later, but when doing that critical value is when you're doing means and sigma's unknown. Okay, you're going to notice the same thing's going to happen in chapter 9. I'm going to teach you how to do something whenever sigma's known. And then we're going to go, okay, well, what about when sigma's not known? Okay, when sigma is not known, okay, that's when you're using that student's T values. For this right here, we're going back to using that critical Z value, okay? Just so you know, okay? Like I said, I'll just kind of have to use the PowerPoint today or my notes, which are already downloaded for you, by the way. Look here. And we just kind of parse through this. I'll just kind of like highlight some highlights areas here. Notice we're using the little p hat thing that we learned about. Okay, that's a proportion. Okay, in that proportion, you have a certain number of successes or failures that you're measuring, and then you have a total number of outcomes. Remember, that's proportions. Okay. For this one right here, you can see it says a graduate student wishes to know the proportion, okay, of American adults who speak 2 or more languages. He surveys 565 randomly selected American adults and finds that 226 speak 2 or more languages. Long story short, he does the math to this and finds that 40% of those he studied speak 2 or more languages. I did ask the students yesterday, let me kind of get your opinion. Does that sound high? 40% speak 2 or more. What I found yesterday is, guess what people weren't counting? English as a language. They were thinking someone knew English and then 2 other languages. If you count English as a language, which you should because you speak it, but then think about people who speak Spanish or any other language, or Chinese, or Arabic, or Pakistani, or something like that. So could it be very well possible that that population speaks 40%? That makes a little bit more sense whenever you actually count English as a language. So it was kind of funny to kind of think about how we don't really sometimes think of our own language as the language being counted. Okay. So notice, I want you to realize here that our new point estimate is now going to be that p hat. Okay. So that's going to be the guy that you're plus and minusing from whenever you find an areolator. Okay. Kind of help you remember that? Okay. 2 ways you're going to know you're dealing with a proportion. One, they're going to tell you proportion. Or, hint, hint for the final, because I'm going to be doing this left and right. You got about 2.5 weeks before the final. Okay. Look for a percent symbol. Then you know, okay, I'm dealing with a proportion on this one. Then your brain can go, what calculator button am I going to use? Or what formula do I need to look at on my formula sheet? Okay. Probably going to have a p hat somewhere on there. And that'll at least narrow it down for you. Okay. Here we are. We still got some rules that we need to follow by. Notice you got to make sure some conditions are met again. Okay. Because we're still dealing with a central limit theorem. Certain things have to work or have to be in place for this to actually work. And so for this one right here, it's going to be make sure everything has been sampled correctly. It's a simple random sample. Make sure the sample size is large enough. That means your n times p has to be greater than 10. Remember, you've done that before. You did that back in 7.2. Whenever I taught you about the central limit theorem with proportions. These are the same things you did in 7.2. We're just making sure that now for the central limit theorem to work with proportions, we're keeping all the conditions working. Okay. It is a good idea to check this stuff. Okay. Once again, because I want to help you, your conditions are going to be met online. Okay. It's sort of like the old thing, like I still have students like right now in my intermediate class who want to put not factorable for stuff. And I'm like, I showed you the quadratic formula. There's nothing not factorable for you anymore. Okay. So sort of the same with you right now. There's not going to be really, the conditions are always going to be met because I'm not going to give you like that little freebie question where it's like, oh, I'm done. No, it's going to work. I'm going to want to see some math. So let me show you here. Look at this guy right here. Once again, I did all the math for you right now. Because the computer's not working. So you're in luck. But still, this is all, remember, all this is downloaded onto your computer too, onto your Canvas shell. But let's also start parsing through the information. Notice all I'm doing right now is checking to see if conditions are met. Okay. So the very first one gives me n is 45. My p hat is 0.18, which is 18%. Okay. And so I start doing the math. I start plugging everything in. And notice here, that is not greater than 10. So at that moment, really, me doing this whole other part here, that didn't need to happen. I just did it to go and finish it off, right? But because one of the conditions was not met, I don't have a valid way to do this, okay? So you'd have to say, oh, can't do it. Now, and I'm gonna be honest with you, I don't know what Hawks is going to tell you. I don't know if they're gonna be like, hey, let's go ahead and if they give you a button or whatever. So you may let me know. But notice the next one. Once again, I have to calculate my own p hat, okay, because it says for a randomly selected group of 90 adults, 34 had been administered the shingles vaccine. Well, that means 34 out of 90, which comes out to 0.38. Now they gave me the p hat. Now I start doing all the math, do the conditions work. Well, yeah, because look, when I do the first one, I get 34.2. When I do the second, I get 55.8. And what's really nice is if you want to do some quarterly kind of quick check to see if you did everything right, both of those, when you add them up, they're going to equal 90. Because think about it, one is this percent, and then one is what? The complement. That's all you did was you found the complement of it. okay? And so both conditions have been met, and you get my little happy face. Are you good so far? Okay, well, let's get into the formula. There's gonna be your new error, right there. Okay, remember our point estimate now that we're having to look at, the new point estimate is going to be that proportion, that p hat. That's gonna be the guy we're gonna be plussing and minusing from here shortly. You'll also notice they're not worried about degrees of freedom in this one because there is no standard deviation involved with this one. They're literally just worried about the proportion, that p hat, your 1 minus and your n value. Okay. You should also notice, if you'll notice right here, look at they're using. They're using that critical value that you have in your book. Okay, so you have to go back to your book, look at it and go, okay, at a 95% confidence interval level, you got to look over, scan over, what does it say? At 96 or whatever, okay, they're always going to be standardized. I'm not going to give you a weird one you have to calculate. It's going to be in your books. So far, so good. I will give you this formula on your final. You'll get a sheet of formulas and tables, okay? They're not in order. Okay, I don't put them in classifications of, you know, this chapter, this came, they're just gonna be on there. Randomized, okay? So you need to kind of have an idea of what you know, kind of got to parse it out. If I see p hat, I know I'm dealing with proportion because I don't have a p anywhere else. It's always gonna be that p or p hat, okay? And then once again, to find our confidence interval, the little hint, knowing I'm in chapter 8. Okay, I'm gonna be using my new point estimate, that unbiased estimator that you learned about in 8.1, and say my p hat, I'm gonna have to plus and minus from there. Okay, and that's exactly what that's saying. And once again, you can put it however you want. But remember, if you put it in this way, okay, remember that is not a coordinate point. That's that interval notation. Okay, it's giving you some bounds. It's saying, I think that percent, that proportion I'm looking for is going to be what? In between here and here. Is it probably? Probably. But is there a chance it's not? Yeah. Because remember, you're just taking samples right now. This is the same thing as when you were dealing with means. I think my actual mean is between here and here with a 95% confidence level. Could it not be? Yeah, it very easily could be over here somewhere. We don't know. But we have to have something that works. And that's how come we back it up with the central limit theorem. Why do I say that? Because once again, don't forget on your assessment, it's going to ask you, do the math, tell me the math, and it's going to give you like a little listing of things going, what did it just tell you? What did I just ask? Okay, and you've got to go in there and put that down. Need to know the context. Don't just do the math. Walk out of here knowing something. There. Now look at this. 2 ways to do it. By hand or by calculator. Now be careful. I would get out your calculator because everybody in my class yesterday did it wrong. And I could not figure out why they did it wrong until I realized people don't keep reading. You have to scroll a little bit further than what you realize. Okay? If you start going onto your calculator, the first thing you're going to hit, if you go to stat, test, and then you go to a 1, if you hit 1 minus prop z, the first very 1 minus prop z you're going to see is a 1 minus prop z test. That's the wrong button. This is prop z interval. Okay, because we're looking for that interval. Okay. So once again, I parse out all the information. I even check my n and p value. Okay, my n1 minus p. Of course, both of those work out. Notice I get a greater than 10 on both of them. That's kind of a rule, right? I got to have that. I look at my c value. My confidence level is 95%. 1 minus c gives me 0.05. I need to divide that by 2, and I get 0.025. Or you can just look it up on your table. Right? When you look it up on your confidence table, you end up finding out that your confidence interval that you're going to need to use is this 1.96. And I start plugging everything in, and that's what it is at the very bottom there, is I just plug that number in there. And then notice, it's literally, the hardest part really is kind of parsing out all the information. Okay, what do I need to use? Now, the hard part about using your calculator, you've got to do some math. Okay, because notice, there's a number that I'm putting in my calculator that I don't give you. I don't give you that one. Okay, they don't give it to you at all. But if you remember, let me write this in blue. Let me kind of come over here. Notice that to find p hat, there's the formula. Okay, well, notice they give me 0.61 is equal to, I don't have an x value, but I do have an n value of 820. If I solve for x, that means multiply this guy up, I get my x value, and that's how I got that 500 right there. Okay, you multiply by that percent value times the total number, and it's going to give you that x value. Your calculator wants the x value because it's going to do its own proportion. It doesn't want you giving it the proportion. It wants to see the x over n, the actual values you use to get that proportion. Okay, so that's what you got to watch for. Which also means this. At times, your calculator is going to be a better level of exactness than you will be, because you're going to already be rounding your proportion, whereas it's going to be going, I'm going to all these little infinite proportions that are out there, and so there may be a little bit of variance, just very slight, especially depending on what level of exactness they want, whether you're going to the 10, hundredths, thousands, or so on and so forth. Okay. Notice when you put that into your calculator, you should get, once again, the same thing I got right there. So let's double check, and I'll do this on my calculator as well. Are you okay with the formula? Parsing out the information that way. So you hit your stat key, go over to stats. And this is what they were doing yesterday. Notice they immediately just went, they stopped right there. They saw 1 minus prop z, and they just were like, that's it. That's not the right one. You will be using that. It's a good idea to kind of remember those buttons, those test ones, but you're not going to use it right now. You've got to keep scrolling down. And there it is right there. 1 minus prop z interval. We don't use 2 in this class. 2 is for 2 variables. Okay, if you ever wonder what that is. We only do, this is only a single variable statistics class. That means you're only worried about one thing happening. Okay, we don't worry about things happening in more than one area. So notice whenever you click on this one, hit enter, and there you go. Same exact information as I had. You got the 500 that I had to calculate myself, right? Then you got the 820. They ask you for the sea level, hit calculate, and there you go. Notice they told us 61%, right? But the actual, the official one here is 0.6097, so on and so forth. So notice that there's a little bit of variance in there between what you actually calculate by hand compared to what your calculator does. It's because of that level of exactness that your calculator is willing to do. So don't be, Pops will know the difference. Okay, so don't worry, okay? And then specifically looking at this number right here, if you look at, my calculator says 0.643. You gotta look what I got there, 0.652. It's because of that level of exactness the calculator did. Okay, so don't worry, Hawks will know the difference on that. Okay, I will too. Every single one of your tests on Hawks, I'll go put eyes on it because I get it. Have y'all done a test in Hawks? You accidentally put a space and it counted wrong. Okay, I'll go in and double check that, and I give points. Okay, good. We okay with that? Let's do another one. What about sample size? Well. Okay. Minimum sample size. Okay, I need to know that one. Hardest part about this one, where I always messed up, one, your calculator doesn't do this for you. But where I always mess up on this one, I always forget to square it. I do everything and then I forget to square it, that one little section over here. Okay, so you're obviously all very much smarter than me, so please don't forget to square it, okay? Trust me. I will do problems of yours online, like, what am I doing wrong? I'll get mad, walk away, go have some coffee, come back, still get it wrong, and realize the whole time. You weren't squaring it, you moron. And then that's where I was messing up. And then I feel stupid. So I'm like, okay. But then, like I said, you know what the problem is usually? It's going too fast. Too cocky. Okay, so slow down. And this is another one of those, you know, when somebody says, well, how do they know they took the right number of samples? There you go. Just like you learned in 8-1. What's the minimum number of samples? You got a formula for that now. But just remember, you always round up when doing samples, okay? Round up for samples, round down for degrees of freedom. Okay, I know that sounds kind of weird. I'm gonna try to help you with that. We round up for samples, we round up for the sample sizes because there's still part of a human there. So that sample size is part of a human, part of a trial, part of something you're studying, and you don't want to have that little part of them in there. So you go and just give the rest of them. Okay, whereas degrees of freedom, remember, that's a sample size. So if you're using your chart, and I really specifically mean this for people who have to use their chart, looking at the t-interval, you have to round down, because if you'll notice on that chart, after a while it starts skipping numbers in chunks. It's like 700, 750, 800. Okay, you always round down when doing degrees of freedom, because if you don't, you're adding a lot of people into your sample that aren't there. So it's always better to err on the side of caution and take away than it is to add to, okay? So here's an example. Line there. Once again, let's parse this out. Okay, since we're having to use my notes today, or your notes, this is what I give to you. Notice I write down the formula. Always making sure I put that guy there because I don't want to forget him. I look up the p-value, it gives it to me of 0.54, okay, which is right here. So I put those built in. And then I say, okay, well, where do I find that critical z value? Well, that's going to be in my book. Okay. Well, what's the z value I'm looking for? And that's going to be 99%. And I know that 99% is 2.575. That's the number I'm looking for, right? And then they give me an e-value of 0.02. That's right there. That's that. We desire no more than 2% margin of error, okay? So keep an eye out for that. Sometimes they may make you calculate the error and then do this, okay? Which you can do that. You can find error. You've got the formula for it. We put everything into our calculator, do our math carefully. And we get 4,117.6, but we got to remember that 0.6 is a human. We're going to go ahead and get to err on the side of caution. We're going to go up to the nearest whole number. Never down, always up, okay? And then it's after this, and I say this because you're going to have a project here pretty soon. I think it's already, I think it's opening on the 13th. It may ask you on there, what's the minimum sample size you need to do this, okay? But it's going to give you all the information possible for everything. Good so far? Pretty straightforward. Let's do an example here. Let's see if I can kind of pull that here. Let's do this one right here. There. work this one. And then I'll show you my notes. The State Education Commission wants to estimate the fraction of 10th grade students that have reading skills at or below the 8th grade level. In an early study, the population proportion was estimated to be 0.2. Okay, how large of a sample would be required in order to estimate the fraction of 10th graders reading at or below 8th grade level at a 98% confidence level with an error of at most 0.3? Round your answer to the next integer. Okay. You're going to need to parse out the information. Okay, so start thinking about it. What's your n value? You don't have it. That's what you're looking for. So what's your p? So write that down. Remember, your P is not the 98%, that's your C level, that's 98% confidence interval. Be careful of just finding that percent value, and oh, that's my guy. That's not your guy. That C is your 98% confidence interval. Remember, that's the interval you're trying to make right now, okay? For the number you would use. Someone gets done pretty quick, give me a thumbs up. Here. Yep. That's done. What you're getting past is that note card I promised you for your final that you can use to write down stuff. And like I said, for those online, you just need to make sure that you only use a 3x5 note card. I don't care what color you use. But you're allowed to use that on your final. You can put whatever notes you want on there. Now, mind you, I'm giving you a formula sheet. Okay, so I say that because real estate's expensive. Okay, so you're only got 30 square inches to work with. Okay, but I will give you a hint. A Bic 0.05 mechanical pencil writes the smallest. Okay, but they are very, very fragile.
Can we do front and back?
Back. Okay. Do you want? Did you want?
Yes.
Okay. All right, let's look at my answer here and let's see, did you get that right there? Did you find your C value of 2.33? You should have found that in your book. Your P value of 0.2 and an E of 0.3. I pop all that into my calculator and I get 965.13, but I can't do that because I'm only counting 0.13 of a human. And so let's round it up so we get a whole nother person in my sample size and make sure that turns into 966. If we were back in 8.1, or because I don't think I showed you that in 8.2 or 8.3, maybe I did, I forget. So many numbers, right? What will be my degrees of freedom if a question asks you for this right now? Exactly, just -1, right? Your degrees of freedom is always -1, okay? You don't need degrees of freedom when dealing with proportions, but you do need degrees of freedom in 8.3, right? That is very important for that one. All right, a survey of 123 randomly selected students at one college showed that only 80 check their campus email account on a regular basis. That's a lie. Okay, construct a 99% confidence interval for a percentage of students at the college who do not check their email account on a regular basis. I say this is a lot because I'm a professor and none of y'all check your email. I will get an email from you, email you back within minutes, and then I'll ask you a question, I get nothing. It's like y'all text me and go, what y'all do?
I used to count off on that. Did you know that if you email me and I emailed you back within 5 minutes. And you didn't email me back at all, I took points off on a test grade. I still do, actually, it's still there. That's that self-community and communication grade. So. That annoying girlfriend, like, you're gonna hear me. Alright. So. Try that one out. A survey of 120 randomly selected students. Figure it out. See if you can't figure it out. I'll show you my notes. Can you use it by hand? Or can you use your calculator? What would be the button if you use your calculator? 1 minus prop Z interval, not test. Interval, 1 minus prop Z interval, exactly. You got right here? Get that? Did you read it right? Look at the question. A survey of 120 random selected students at one college showed that only 80 check their campus email accounts on a regular basis. Construct a 99% confidence interval of students at the college who do not check their email on a regular basis. So it wouldn't be the 80. You would need for your X value for it to be a 43, not the 80. They were trying to fool you because they changed it to not at the very end. And so therefore, your N would be 123, your X would be 43, your confidence interval 99, 1 minus prop Z interval, there would be your interval. But remember, they want it rounded to 1 decimal place because it says it right there in the question. And so it would be a lower endpoint of 0.2 and an upper endpoint of 0.5. Get it? You need to work on my calculator, you good? You okay on that one? Yeah. Come in here, remember you go to, oops, sorry. That. Test. All the way down to A, 1 minus prop Z interval. Hit enter, notice I've got an X value here of 43. I have an N value already put in of 123. My confidence level is 99% as stated in my question, right? Hit calculate and look what I get there. Look at the very top numbers. I get 0.2385 884, comma 0.46034, or rounded to one decimal place, 0.2 and 0.5. Good, you okay with that one? Once again, you can do it either way, okay?
Yes.
You can come back in here and do the math to that too. And notice I've got this 0.349 plus, okay, if you did the 0.110, and that would give me 0.459. Okay, it's not as exact, but I'm only going to one decimal place, okay, if I did that on my calculator, okay? So my e-value does work that I calculate myself, I just go plus and minus from there and it won't be as exact.
So on your notes, you have 23.9.
I got it wrong.
Because it's percentage, or because you moved the decimal? For
I
the-
moved the decimal and I shouldn't have.
Oh, so leave it like that.
Yeah, leave it like that. Yeah, I moved the decimal because I turned it into a percent. I'm bad about turning things into percents because I like to see percents all the time. You should not do that. Don't fall into my bad habit of turning things into percents when they shouldn't be. Okay? Good? Okay, and if somebody will email, I'll remind that if I always forget, sometimes I keep the mistakes in the notes just because I like to see who catches them. You know, I used to get bonus points for that. If people caught mistakes in the notes. I don't anymore, so don't start going on look as well. Because there people will be like, hey, I found a period that you didn't put down. Okay. Let's do another one. One last one and then we'll be. Ah, that's a good one. It'll be my second. All right. The FBI wants to determine the effectiveness of their 10 most wanted list. They need to find out the fraction of people who appear on the list that are actually caught. Step 1 of 2. Suppose a sample of 278 suspected criminals is drawn. Of these people, 88 were captured. Using the data, estimate the proportion of people who were caught after being on the 10 most wanted list. And your answer has a fraction or decimal number rounded to 3 decimal places. So what am I looking for? I'm looking for my what right now? That what? P at. So figure it out for me. Tell me if you. And then I'll show you my notes. Did we read the question carefully to make sure that they weren't twisting it at the very end? Right? Always double check that. Proportion ones are really bad about that. If y'all kind of want a little hint, Hawks is really, I'm not gonna say bad, but it's kind of good. They're really bad about giving you a bunch of information, and then in the question part of it, they flip it on you, just like they did the last one. They said, this is the percent, this is the number of students that answered their email. And here's all the number of students we did. And then right at the very end, they go, how many don't? Right there at the very end, they change it on you. Okay, so be careful about that on those proportion questions. Okay, they're really, they can get tricky. Okay. Should know that your p hat, the formula for that is x over n, so you need to know the x value. What is your successes? What do you count as a success? What do they count as a success? All divided by the total number of outcomes. Hopefully you got that right there. Of 0.317. Because we were looking, how many were captured?
88.
Exactly. How many is the total sample size? 270. And then we just do simple division and we're good to go after that. Okay, well, since you got that, since you know your 3.0, sorry, your 0.317, let's go to step 2. Which says same thing, but now look at what they're changing on you. Suppose a sample of 278 suspected criminals is drawn. Of these 88, 80 were captured. Using the data, construct an 85% confidence interval for the population proportion of people who are captured after appearing on the 10 most wanted list. Round your answer to 3 decimal places. Once again, we are what? We're looking for a confidence interval. So step one in my brain, if I was sitting here going to take the test you're gonna take, is I'm in chapter 8. That's literally where my brain's going. I'm in chapter 8. Okay, am I dealing with means? Nope. Do I see standard deviations anywhere? Nope. I see a proportion. Okay, now I know I'm an 8.4. Okay. Kind of narrowed down, and I'm building a confidence interval. Okay. So my point estimate's going to be my 0.317. That's going to be the guy we're going to do what to. If you did this by hand, you got to find your error. That's the guy you're plus or minusing from. Okay, that 3.17, 0.317. I apologize. You have an N value, 278. You have a C value of 85%. If you were using your table, you need to look that up in your critical values of Z table. Okay, I can tell you right now that that number would be 1.44. Then you take the square root. Or what button are you putting on your calculator?
100 comp Z.
Yeah. Do you think I care if you put down calculator buttons on your note card? I don't care. I do not care at all. Okay? Like I said, you put whatever you want on there. Okay? When you get done with this one, hopefully you got my answers, and I did do them right this time. Look there. By your calculator, you have an X value, the total number of outcomes you want of 88, N value of 278, my C of 0.85. Or by hand, once again, there's your formula. And I use 0, remember, I go to 4, when it tells me to go to 3 decimal places, notice where my calculation is to. It's to 4. Okay, so that way when I do my math, I'm rounding up to that 3rd place. Remember, if you're going to 3 places, always calculate to the 4th place, okay? Or you use your calculator and then there is your answer right there. But before you leave, what is that saying? Literally, what is that telling you right now? Is my true proportion true? My very true proportion, is it what? What it has up there? Or is there a variance in there? And we kind of have an idea. We're like, we're pretty confident. How confident? 85% confident that our true proportion is what? In between those numbers. Are we exact? Oh, do we know for sure? No. But we have an 85% confidence interval that we can think it's gonna be in between there. That's what we're looking for. Okay, that's very important as we finish up 8.5 next week, and then we're gonna get into probably the more murky area. This is one of the students called hypothesis testing, okay? So remember, bring your book next week, okay? Or do what I told students yesterday. If you don't carry that whole big old book, I get it. Take it to the library, go copy off the front cover and the back cover, where those tables are. So you can pull those up and look at them, because you're gonna need do you have anybody have a book for it now? Let me show you what you're gonna need. Because you're gonna have to have this one. So you can go take a copy of it for like here. If you go to the very back page of your book, right here, okay, it's gonna say what to you is gonna be looking like x squared. That is not x squared. That's a capital X, okay? That's called chi-squared, okay? More Greek, okay? You have to know this, not know it, you're getting to use this on your test, okay? It's called a chi-square distribution. It's another type of distribution. So you've got normal distribution, binomial distribution, which is still kind of the same for us. You don't have to worry about that too much, but we have that student's t distribution, and now we have a chi-square distribution, okay? That's what we're going to be going over probably the whole of class, more or less, on Tuesday. But you need that. Okay, so just so you know. All right, guys, I will see you all later.